Assalamualaikum, my name is Muhammad Afif bin Muhammad Rais. Today, I'm going to present about traffic noise study. First, what is noise? Noise is to be understood as every kind of sound which is undesired, disturbed or irritate, and which decrease physical, physiological or social well-being. In modern society, road traffic noise is probably the most significant of the environmental noise source. The traffic noise consists of vehicular engine noise and the tire noise from the contact with the roadway surface. This traffic-generated sound wave can be described by two basic parameters, frequency and amplitude. Frequency refers to the number of waves produced within a given time period expressed in unit of cycle per second. Amplitude is the energy level of loudness of a sound wave expressed in unit called decibel. Traffic noise can be vary considerably over a short time period. Traffic noise is therefore expressed as the percent of time of sound level is exceeded, denoted by L10. The unit of traffic generated noise is decibel A, weightage dBA. The objective of the test is to determine the traffic noise level at L10. L10 is the level exceeded for 10% of the time. For 10% of the time, the sound or noise has a sound pressure level above L10. For the rest of the time, the sound or noise has a sound pressure level at or below L10. These higher sound pressure levels are probably due to sporadic or intermittent events. L10 is often used when assessing traffic noise and in planning application. L10 is the level exceeded for 10% of the time and take account of any annoying peak in noise. So, the apparatus used in this experiment are noise meter and stopwatch.
Now, for the procedure on how to conduct the experiment. First, we choose the location. The location I choose is road near Sekolah Kebangsaan Seksyen 7 and Taman Kristal. First, the meter was powered and desired time response either fast or slow, and frequency weighting A or C was selected. If the sound source consists of short bursts or the application called for capturing only sound peak, set waves and mean response to fast. The slow setting was used to measure average sound level. Select A for waiting for average flat. Response sound level reading or C is for waiting for human ear response simulation where the tests are conducted for personal safety analysis. Next, the desired range manually or enable the auto range function, which is range between 30 to 130 dB, was selected. This instrument was held comfortably in hand or positioned on tripod. The microphone was pointed toward the noise source. The sound pressure level was displayed on the meter LCD display. The instrument captured and hold the maximum noise level reading on the display when max or maximum hold mode was selected by pressing the max key. Then, the max key was pressed again to clear the max reading. The sample was taken for 30 minutes using table and analyzed to determine the estimated L10 value. Finally, the instrument was turned off and the battery was removed when not in use.
Now, let us move to data acquisition. As we can see, the data show the study was conducted for 60 minutes and each data with interval 30 seconds. The data was changed into a graph as shown. The graph showed the pattern of the noise level. Then, we tabulate the data into a statistical analysis. As we can see, the table consists of noise range, mean noise or L, frequency or F, percentage of frequency, cumulative frequency, FL or frequency times mean noise, and frequency times by power of mean noise. From the table 2, to calculate the L10, we use the formula L90 plus 90% time and number of data plus 1 minus by FL90, which is 1 plus 5 plus 16 plus 22, and divided by FM90, which is 16, then times by C, which is 4.9. Then we get the L10 is 83.34 dBA. This is the pattern noise level with percentile level. Then we calculate the arithmetic noise by using formula summation of FL divided by summation of F. Then we get the value of 76.25 dBA. As for the median, we use the formula L50 plus 50% times and number of data plus 1 minus by FL50, which is 1 plus 5 plus 16 plus 22, and divided by FM50, which is 22, then time by C, which is 4.9. Then we get the L50 is 76.89 dBA. From the result, we managed to determine maximum and minimum value of the noise level at SK Section 7 and Taman Crystal, which are 64.9 dBA and 84 dBA respectively. From the formula, both maximum and minimum value were used to calculate L10, which is 83.34 dBA. According to the table, the noise level was exceeding than the required noise level standard, which is 55 dBA. The recorded data was quite high because the road was busy during peak hour, which lead to the source of the noise pollution. The vehicle noise may cause disturbance to the student as it will affect their study, their productivity, and can cause stress. During conducting the experiment, we took precaution measures to avoid from causing error to the data. We need to remain silent when using the noise level instrument as the instrument is very sensitive to the sound. In a conclusion, the traffic noise level at L10 can be determined through the experiment conducted. The value of L10 that we calculate is 83.34 dBA through calculation from the table data collected. The L50 for the experiment is 76.85 dBA and the L90 is 80.8 dBA. The mean noise for the experiment is 76.25 dBA. Thank you.